Good day everyone, and welcome to another video of Frank Edu Solutions. We did our first video on why students struggle in math and science, and today we have been going on reviews to find out which topics students actually find difficult so that we could bring it to you and you could enjoy it and know those topics. So one of those topics is what you're going to be looking at today, and we're going to be looking at mathematics. And the topic we're going to be looking at is partial fractions. I term these partial fractions one because we are going to try and create a background before we really go into partial fractions, and the background is the knowledge of fractions. So it is important for us to understand fractions before we go to partial fractions. So I'll be teaching us the addition and subtraction operation with the division and multiplication operation of partial fractions or fractions after we can go to partial fractions. So let us understand what is fraction. Fractions basically is part of a whole, and if you understand that as part of a whole, then you have no problem with fractions. So let's consider a ball, a whole ball. So since fraction is part of a whole, let's assume this ball has an area or has a unit of x, and if you cut a particular part of this ball, which is a fraction of the ball or a part of the ball, and let's call this part maybe 2. Now, out of x units, you cut out 2. So simply what we have done is to cut 2 out of x. So mathematically, to represent 2 out of x, it's simply represented by 2 over x, with 2 called the numerator and x called the denominator. So this is going to be important as we carry out the basic operations of fractions. So let's look at the first operation, the addition operation. Okay, addition operation. Now, but before we go to the addition operation, it's important to note that we have 3 types of fraction. We have the proper fraction, which is simply when you have a smaller number up as the numerator and a bigger number as the denominator. Improper, when you have a bigger number as the numerator and a smaller number as the denominator. And then mixed fractions, when you have 3 different numbers coexisting in a fraction, example like 2 over 1 over 2, and so on. Okay, so these are examples of various types of fractions. So let's look at the addition operation. Let's use a simple fraction. Let's use that to be consistent. Let's use x over 2 and plus y over 5. The first thing to do is to find the LCM of the denominator, which is 2 and 5. And what can go into 2 of them is 2. 2 divided by 2 gives us 1, 2 and 5. Because 2 can divide 5, it's up at 5. We can't use 1. 1 can go into 2 of them, but we can't use 1 because when you use 1, you still get 2 and 5. So it's a waste of time. So now that we've used 2, what's the next number? 3 can go, 4 can go. Let's say 5. 5 can go. 5 and 1 still remains 1, and 5 and 5 gives us 1. So we're going to 1, nothing more can divide them. So our lowest common multiple, which we needed to find, is 5, which is also there, which gives us 10. Having gotten this 10, then we can go forth to finish the question. So we have x over 2 plus y over 5. And we got that the LCM, the lowest common multiple, is 10. Then 10 divided by 2 gives 5. And 5 times x gives 5x. So plus 10 divided by 5, it gives 2. And 2 times y, 2y. By this, we have been able to successfully solve an addition operation involving 2 variables. So let's take a look at the subtraction operation. There's simply no difference, as you will see. There's simply no difference, but I'll try to twist it a little so that you don't get confused when you see questions that are not this way. For example, if you have a numerator as the number and the denominator as a variable, and you're minusing from the numerator as a number and the denominator as a variable. It's simply the same thing. Do not be scared when you see such a question. Say, oh, I wasn't taught this. No. Simply treat it as a number. So take x and y, which are denominators, and try to find the lowest common multiple. So as a letter, x cannot be divided by x. So x and x gives 1, and x and y can go, so we have y. So we use y and 1 and 1. So our lowest common multiple should be x, which is this x, times y, which gives us x, y. Note that sometimes you may have to divide 4 to 5 times, or 6 or 7 to get up to 1, 1, but always try to get to the end where you have 1 and 1. Those are the lowest common multiple. So, having had this, then you have 2 over x minus 5 over y equals to, so the LCM is x, y. So xy divided by x, so you can see x and x goes off, remaining y. You have y times 2, which gives us 2y, minus, you have the xy divided by y, y and y goes off, x is remaining, x times 5 gives us 5x. So this way we have been able to solve the subtraction operation, and our answer is 2y minus 5x over xy. Then we're going to go to the division, the multiplication operation. Before we go to division, let's start from the multiplication this time. What happens in the multiplication is actually quite simple from the addition and subtraction, because this doesn't involve any lowest common multiple. All you have to do, if you have 2 over x times maybe y over 5, so all you have to do is 2 times y, which gives you 2y over x times 5, which gives us 5x. So we can't write x5, we always write the coefficient before the variable. So we have 2y over 5x. Let's look at the division operation, which isn't different from the multiplication operation. The division operation is quite similar, very quite similar. The only difference is this: when you have 2 over x divided by y over 5. What happens? Simply, we have to change the division to multiplication, and when that happens, in the other part, not the first part, the second part, the denominator becomes the numerator, and the numerator becomes the denominator. So what happens? 2 over x, divide between 2 times, and the denominator 5 becomes the numerator, and the numerator y becomes the denominator. And then you have 2 times 5, which is 10, and x times y, which is xy, as you can see. So the addition operation is just quite similar. So like this, we have been able to understand the basic operations of fractions, which is the footstool into the partial fractions proper when we do that. So let's not forget to like our video and to subscribe to our channel. We are trying to get a good number of subscribers so that a lot of students can learn from this, and also hit the bell button so that you get notifications when we post more videos. And please always don't forget to keep solving. The more you solve, the better you know. Thank you and goodbye.